Right, final question. A couple of proofs. Question 14, part 1. We've got to prove. I'm not going to write that all out. Why do I want to write all that out? It's right there. Prove that the sum of the squares of two consecutive odd integers is always 2 more than a multiple of 8. So we have to concentrate on this. 2 consecutive odd integers, and it's a sum, so we're adding them. So we have to define our variables. So I'm going to say let 2k minus 1 and 2k plus 1 be consecutive odd integers, where k, of course, is an integer. Okay. You can use 2k plus 1 and 2k plus 3. I think it's a little bit easier with this because things cancel out a little bit more nicely than if you use 2k plus 1 and 2k plus 3. So then the sum of the squares. So we want 2k minus 1 squared plus 2k plus 1 squared. Okay, the sum of the squares equals, we just got to add them. So unfortunately, it's not the difference of 2 squares, it's the sum of 2 squares. So we've just got to work this out. So 4k squared minus 4k plus 1 plus 4k squared plus 4k plus 1. And that's what I was saying about things cancelling out, because that goes with that. And you're left with 8k squared plus 2, which is exactly what we wanted, which is 2 more than a multiple of 8, therefore proved. Okay, and again, you do need a conclusion of some sort. It doesn't have to be an essay, but you need to refer back to the thing that you're trying to prove. Okay. If you did 2k plus 1 and 2k plus 3, you ended up with a more complicated expression here. But so I'm not going to do it all, but if you did 2k plus 1 squared plus 2k plus 3 squared, you still need to try and manipulate it into 8 times something plus 2. Okay, so try and get it into that form. So 8 times expression plus 2, so that you can then make the same conclusion. Okay. Obviously I haven't done that work. Okay. Second part, I've seen this sort of thing come up a couple of times. You've proved by contradiction to show that log base 2 of 5 is irrational. So we're trying to prove that log base 2 of the 5 is irrational. So our counter statement, our assumption, is that log base 2 of 5 is rational. Okay, so therefore, let log base 2 of 5 equal a over b, where a and b are integers. Some people went to great lengths to explain that a over b must be a fraction in its simplest form. That is confusing this proof with the root 2 proof, because it is that the very fact that the fraction is in its simplest form, which you then later contradict. I don't think it's critical here for a over b to be in simplest form. It just has to be a fraction. So just to mention that. Now, where do we go from here? We've got to somehow end up with something that's not true. Well, there's only really one place to go from here, isn't it? Which is to turn the log statement into an exponential statement. So from here, we go then 2 to the power of A over B equals 5. Well, that's not really very, and some of you got this far and got stuck. That's not a very easy statement to contradict. But if we raise both sides to the power B, right? So effectively raising both sides to the power B, then what we get is 2 to the A equals 5 to the B. Okay. So therefore, 2 to the A equals 5 to the B. Now, this we can contradict because, and there's various ways to explain this, 2 to the power A, where A is an integer, must always be an even number. 5 to the power B, if you think through your first few powers of 5, 525, 125, 625, they all end in 5, right? So, but 2 to the A is even, and 5 to the B has last digit 5, therefore it's odd. Therefore, we have a contradiction, and therefore we go back to our original statement. Therefore, log base 2 of 5 is irrational. Okay, so that is the proof. No other way of doing it, really. I mean, quite a few people got as far as this bit in the middle, but then kind of, I guess you got stuck as to saying, well, how do I disprove it? You just have to think it through and think, well, how could this possibly equal to this? Powers of 2. Think through a few. You know, 2, 4, 8, 16, 32, 5, 25. How could they ever be equal? They can't, because one's always even and the other one's always odd. So that is it. That is the end of that paper and question 14. So I hope you found some of that useful.